is very similar to what we talked about on Friday when we were beginning to talk about ways to count options of selections. The first question says 12 skiers are competing in the final round of an Olympic freestyle aerial competition. How many ways can the skiers finish the competition, assuming there are no ties? So this is similar to what we did on Friday when we set up, and I'll make 12 blanks, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if these people all made it to the finals of the Olympics, in theory, they're all very good and anybody should have a chance to win. So in the first blank, how many people could get first place?
12.
Any of the 12, in theory, if they made it there, should be able to win. But once somebody has won, how many people could come in second place? 11, and so on down. And everybody is going to get a place. So we are going to multiply all the way down until the last guy gets placed in the last blank. So we could grab our calculator and just do 12 times 11 times 10 times 9 all the way down. But there's a notation for this as well in math. And the symbol we use is the exclamation point. That doesn't mean we don't read that like 12. It's not like exclamation in English of excitement. We're not really excited about the number 12. That notation is called a factorial. So if we're reading that out, we would say it's 12 factorial. That symbol can be found on your calculator. Depending on what type of calculator you have, it will be in a different location. So if you have a graphing calculator, you're going to type in the number 12, or whatever number's in the problem, then press the button that says Math, which is in the first row right underneath the alpha button. Press the button that says Math. Over to the side, you're going to see it say PRB, which stands for probability, which is what we're studying in this chapter. So we're going to go over to that probability menu, and the exclamation point or factorial symbol is there, and you can select that option. If you have a smaller calculator, just a scientific calculator, there should on there somewhere be a button that says PRB, which would mean probability, and that option would be in there. This factorial symbol is also present on I products. If you turn your calculator sideways so you get the more options, there's a button that says X with the exclamation point or factorial. So you could do this on your I product calculator as well. Okay, so when we type that all in, or you could just do the multiplication all the way down as well. That'll work as well, just doing 12 times 11 times 10 all the way down. We get 479001600, or 479,001,600 different ways that those skiers could finish. Okay. Part B says, and how many different ways can 3 of them finish, first, second, and third, to get the medals? Because let's face it, that's why we go to the Olympics, right? Is we want to win, we want to get medals. Nobody remembers who got 4th place except for the person's mom, right? Like, it just doesn't really matter to anybody else who comes in 4th. So how many people could get gold?
3.
12. Out of the 12, in theory, any of the 12 could. And then once somebody got gold, how many could get silver? And then bronze. So this is similar to what we did in Friday, where we're multiplying down, but we're not going all the way down to the 1. So we would do 12 times 11 times 10. And that gives us 1,320 different ways that the skiers could place.
Is that a 3?
Yes. Questions? You have 5 assignments to complete for homework. Part A, and how many different ways can you complete the 5 assignments? Assuming you're going to finish all 5, we've got 5 blanks to fill in. We could do any of our assignments first in theory, because usually one homework in one class doesn't depend on doing another homework in another class first. So we could do anything first, but once we've done that one, we only have 4 left to do, 3, 2, and 1 left to do. So we could multiply that out, or since it multiplies all the way from the 5 down to the 1, this is the same thing as 5 factorial. So we could do that symbol as well. which means start at 5 and multiply down until you get to the 1. When we do that calculation, we should end up with 120 different ways we could do our homework. So when we take out our notebooks and stack them up in order of how we want to do them, there's 120 different ways we could stack up those notebooks. Part B says, in how many different ways could you choose to do 2 of the assignments, 1 to do first and 1 to do last? So I want to know, what am I going to do first? I don't really care about the middle, and what am I going to do last? So sometimes that's an easy choice. For me, I always did the thing that I hated first, just to get it out of the way, because I hated it like hanging over my head. So I would easily pick out what I was going to do first. And I would say the thing that I didn't mind doing for last, because by the end of the homework, you don't feel like doing it anymore. So I'd pick the one that was like, this isn't as big of a deal, and I would do that one last. The middle didn't so much matter. I just had to do what I had to do. So how many could I do first? How many could I do last if I don't care about the middles? 4, because I'm not caring about the middle. So I'm looking at my 5 assignments, and I'm saying, I'm going to do this one first. And once I set that to the side, there's still 4 folders sitting in front of me. And I'm going to choose from those 4 what one I'm going to put off to do last. Some people do their homework the opposite of me and do what they like to do first and save the thing they hate for last. But I found for myself my motivation was waning by then. So I did the thing that I like to do last. So there's only 20 ways to make that selection. Questions? Question 3, you're considering 10 different colleges. Before you apply, you decide to visit some or all of them, because applications have a fee, so you might want to get some out of this list before you pay your application fee. In how many different orders could you visit 6 of the colleges? So I've got 10 colleges I'm thinking about. So how many could I visit first? Any of the 10. And then I've already gone there, so I'm not going to go again. 9, 8, 7, 6, counting down to 5, because I made 6 blanks to fill in since we only have enough money to go visit 6 schools. Okay, or enough time, or whatever it is. So we can do that multiplication, and this is very similar to what we did in Friday's assignment, where we start and then we count on down till all of our blanks are filled in. There's actually a math notation for this as well. We put the number of options we're choosing from in the front, and that's as a little subscripted number. And then we use the letter P, which stands for permutation. A permutation is selecting things in a specific order. So this isn't saying just choose 6 schools to go to. This is saying choose 6 schools to go to in a particular order, because it says how many different orders can you visit. So if we're selecting a specific order to do something, we use this P symbol for permutation. And then after that, we put how many are we doing. We're going to 6 of them. So the first number gives us our whole number of options to choose from. And the second number gives us how many we're actually going to end up doing. We're going to go to 6 of them. This notation is in your calculator as well, in the same place that that exclamation point would be. So wherever that happens to be on your calculator, the factorial and the permutation are in the same menu, except on iProducts, there isn't the permutation. There's a formula at the top here for what a permutation is, but you don't need to memorize it. You could either just write out your blanks and do it this way, or if your calculator has that permutation symbol, you could do that permutation on your calculator. And when we do that for this particular problem, that gives us 151,200 different ways to visit these schools. Now, some of these ways might make more logical sense, like in terms of if 2 of these colleges are in the same town, you might want to visit those on the same trip. So some of these orders would make more sense than other orders, but there are that many different orders we could do. Questions on that?
Wait, so if you don't have a calculator, you just type in 10, 9, 8, 6, 6.
If you don't have, a regular calculator that has the permutation thing, then you would just type in the multiplications. Part B, how could we do all 10 colleges? Well, there we could write out all 10 blanks, And then we're going to do 10 and 9 and 8 all the way down to 1, which that notation is the factorial. If we're going to choose everything, then that's our factorial notation. Or you could use the permutation notation and say that from all 10, we're going to choose all 10. That it would be the same value. But if we do 10 times 9 times 8 all the way on down to 1, we get 3,628,800. Okay. Questions?
If we for the time exclamation point, or 10 will it put it differently, or will it?
Yeah, if the two numbers are the same in their permutation, that's the same as a factorial. There are 12 books on the summer reading list. You want to read some or all of them. In how many orders can you read 4 of the books? So we could do our 4 blanks and say I could read any 12, and then 11, 10, 9, and do our multiplication that way. Or if you have a calculator that has the probability menu, this would be 12P4, the permutation of 12 choices and 4 of them that we're picking to do in a particular order, because it says how many orders. So that gives us oops, 11,880. You guys have more than 12 options on your supplemental reading list, but you often say that you don't have any books to read. But this shows you actually do have a lot of different things you could do. You just maybe don't like any of the options, but you do have a lot of options. If you're going to read all 12 of them, we could make 12 blanks and count all the way down, but that's the same thing as doing the factorial. So if we have 12 to choose from first, and then 11 and 10 and 9 and counting all the way down, that gives us the factorial, which gives us a whole lot of options. And actually the same answer as we had with our skiers, because there were 12 skiers too, right? Questions? Our last type of problem, we're going to look at rearrangements where there may be some. This doesn't happen with people because each person is a unique person. It doesn't happen with books because each book is a unique book. But specifically, our problems are going to look at rearranging letters in a word. Sometimes the same letter comes up more than once. So unless they're colored differently or something like that, I can't tell one O in Ohio apart from the other O in Ohio. So what these questions are asking is saying, if I had tiles or blocks or something that had those letters on them, how many ways could I mix them up so that they look different? Because just swapping the 2 O's, it made a change, but nobody would be able to tell I made that change. Okay? So here is we do the total number of letters, factorial, divided by the number of times that each object or each letter appears, and we take factorials of each of those. So for 5A, Ohio has 4 letters, and then we count up how many times each letter appears and do those factorials. So O appears twice, H appears once, I appears once. We don't need to do O again because we already did it. O appears twice, H once, I once. Okay, so how many times each individual letter appears. Now when you do this division, you don't have to worry about the ones because 1 factorial is just 1, so that's not ever going to make any difference for us. You cannot do the division first. So a lot of times what students will want to do is go, oh, 4 divided by 2 is 2, and then do 2 factorial because that feels faster. And it is faster. It's a whole lot less buttons to push, but it's not true. Okay, so you will get a wrong answer if you do that. You need to do the 4 factorial. You can do it on your calculator. 4 times 3 times 2 times 1 is 24 over 2 factorial. 2 times 1 is 2, which gives 12. Okay? So you have to do the individual numerator and denominator first and then divide those out. But you can ignore the ones because those are just going to be 1, so they're not going to make a difference.
So could we just put 4 over 2?
4 factorial over 2 factorial. Mississippi has how many letters in it?
11.
11 letters. Then we go through and see how many times each one appears. So starting with M shows up once. I shows up 4 times. S shows up 4 times. And P shows up twice. So we can ignore that 1, but we do need to calculate the top and the bottom separately. So on the calculator, I'm going to do 11 factorial. And then I'm going to do separately the 4 factorial times the 4 factorial times the 2 factorial. I can ignore the 1 because that's not going to make a difference, but work out the top and the bottom separately and then divide those. If you try to do too much at once on your calculator, it is likely that you will run into an order of operations problem and get a wrong answer. So it is safest to just separate them. And we get 34,650 different ways that we could rearrange those letters and have it look different to somebody. Okay. Questions? Summer has 6 letters. S shows up once. If you want to ignore the writing the ones, it's fine because we don't do anything with them in the calculations anyway. So we don't really have to write them out. U only shows up once. M shows up twice. E shows up once. R shows up once. So we're going to do 6 factorial, which is 720 divided by 2 factorial, which is 2. And that gives 360. Okay? That is not the same as dividing first and then doing the factorial. Because if you divide first, that gives you 3 factorial, which is just 3 times 2 times 1. That's just 6. Okay, so it's a big difference. Make sure you do the top and the bottom separately and then divide them. Part B. Waterfall has 9 letters. W only shows up once. A shows up twice. T, E, R, F. A we already did. L shows up twice. Once again, do the top and the bottom separately. So the top gives 362,880. The bottom gives 4. And then do your division. If there are no repeats, so if all of the letters are different, then you just don't have anything to divide by. Okay, so if you have a word where every letter is a unique letter, then you just don't have any division to do. Okay. I think about this when I play Words with Friends, and I have like my 7 tiles, but I have 3 E's, and I hit the shuffle button, and I think about like how many ways could they shuffle it so that I can tell a difference, because I can't tell if they move the E's if they're all the same, right? But I'm kind of nerdy. Questions?